Have you ever gazed up at the night sky and wondered why the moon always shows us the same face? It's a question that has captivated skywatchers for centuries. This celestial phenomenon, where one side of the moon perpetually faces Earth, is known as tidal locking. In this cosmic exploration, we'll delve into the fascinating world of tidal forces, orbital mechanics, and the intricate dance between Earth and its lunar companion. Join me as we unravel the mysteries behind the moon's unchanging gaze. Throughout history, cultures around the world have woven myths and legends around the moon, attributing its unchanging face to gods, goddesses, and celestial beings. While these stories add a touch of magic to our understanding of the cosmos, the true explanation lies in the realm of physics. By understanding the fundamental forces that govern the universe, we can unlock the secrets behind this celestial spectacle. From our vantage point on Earth, it appears as though the moon doesn't rotate. Night after night, we are greeted by the same familiar craters, mountains, and lunar seas. This has led to the misconception that the moon has a dark side, a hidden hemisphere, shrouded in perpetual darkness. However, this is a cosmic fallacy. The moon, like Earth, rotates on its axis. It's just that its rotation period is perfectly synchronized with its orbit around our planet. This synchronous rotation means that as the moon orbits Earth, it also spins on its axis at precisely the right rate to keep the same face pointing towards us. Imagine two people walking side by side, with one person always facing the other. The person facing inward would need to turn their body as they walk to maintain this orientation. Similarly, the moon's rotation is synchronized with its orbit to keep the same hemisphere facing Earth. The phenomenon responsible for the moon's synchronized rotation is known as tidal locking or synchronous rotation. It's a celestial dance orchestrated by the invisible force of gravity. Just as Earth's gravity tugs on the moon, keeping it in orbit, the moon's gravity exerts a pull on our planet. This gravitational tug-of-war is what gives rise to tides in Earth's oceans. Tidal forces are differential forces, meaning they vary in strength depending on the distance between objects. The side of Earth facing the moon experiences a stronger gravitational pull compared to the side facing away. This difference in gravitational force creates bulges of water on opposite sides of Earth, resulting in high tides. As Earth rotates, these tidal bulges move across the planet's surface, causing the familiar rise and fall of ocean levels. Section 4. Unraveling the physics. How gravity shapes the moon's rotation. Now, how did the moon become tidally locked to Earth? Billions of years ago, when the solar system was in its infancy, the moon was spinning much faster than it is today. However, Earth's gravitational pull on the moon's tidal bulges acted as a brake, gradually slowing down its rotation. Over vast stretches of time, this braking effect brought the moon's rotation into sync with its orbital period, resulting in the tidal locking we observe today. It's important to note that tidal locking is not a one-way street. While the moon's gravity has a more noticeable effect on Earth's oceans, it also has a subtle influence on our planet's rotation. The tidal bulges created by the moon exert a slight drag on Earth's spin, causing our planet's rotation to gradually slow down over time. This means that in the far distant future, Earth's rotation will also become tidally locked to the moon, and one Earth day will be as long as a lunar month. Section 5. The far side. A hidden hemisphere unveiled. For centuries, the far side of the moon remained a tantalizing mystery. Hidden from our view, it sparked imaginations and fueled speculation. However, thanks to space exploration, we have lifted the veil on this hidden hemisphere. In 1959, the Soviet spacecraft Lunar 3 captured the first images of the far side of the moon, revealing a landscape starkly different from the familiar face we see from Earth. Unlike the near side, which is characterized by vast lunar seas, dark flat plains formed by ancient volcanic eruptions, the far side is heavily cratered and mountainous. This difference in appearance is thought to be due to variations in the lunar crust and the history of asteroid impacts. The far side's lack of large lunar seas suggests that volcanic activity was less prevalent in this region. Section 6. Beyond the Moon. Tidal locking in the solar system and beyond. Tidal locking is not unique to the Earth-Moon system. In fact, it's a relatively common phenomenon throughout the cosmos. Many moons in our solar system are tidally locked to their host planets, including Jupiter's moon, Europa, and Saturn's moon, Titan. Even Pluto and its largest moon, Charon, are tidally locked to each other, perpetually facing one another in a celestial waltz. Beyond our solar system, astronomers have discovered exoplanets, planets orbiting other stars, that are tidally locked to their host stars. These planets, known as hot Jupiters due to their size and proximity to their stars, have one side perpetually facing the scorching heat, while the other side remains in perpetual darkness. Section 7, Conclusion, a timeless waltz in the cosmic ballet. The moon's unchanging face is a testament to the power of gravity and the vastness of cosmic timescales. Over billions of years, the invisible force of gravity has choreographed a celestial dance between Earth and its lunar companion, resulting in the tidal locking we observe today. This phenomenon, once a source of myth and speculation, is now understood as a fundamental principle of celestial mechanics. As we gaze up at the moon, we are reminded that the cosmos is a place of constant motion and change, even when those changes unfold over eons. The moon's hidden side, once shrouded in mystery, is now a testament to human ingenuity and our insatiable thirst for exploration. And as we continue to explore the universe, we are sure to uncover even more wonders that challenge our understanding and ignite our imaginations.